Hello everybody and welcome back to this mini-series dedicated to event-driven programming with the NSC system framework. In this video you will learn how to make a classic Hello World application that will run on a LCDG, a display plus controller device that sports one 64 by 128 display and a small 4 keys keyboard, one RS485L networking data port, one DS1820 thermometer, onboard RTC crystal, a SPI port, one analog input, 3 logic inputs and 2 300 mA 40 volt open collector outputs. Actually, the application that we are gonna make, besides printing out the text Hello World, it will also turn on or off one output that will drive a relay to control a desktop lamp. In the previous part, I've shown how to code event-driven programs and remote procedures calls with the NSC framework for embedded microcontrollers. So if you didn't watch that part, to understand what I will show in this video, I'd recommend to see the previous one first. You'll find the link in the description. Also, if you are not familiar with the concept of event-driven execution and remote procedure calls, I strongly recommend to watch the first introductory part. Again, the link is in the description. I've designed this AppWizard to help making event-driven programs with RPCs and pages to display. This is an example that I've prepared to give an idea of how it works. And here we have the list of the devices in the project, and with the name we have just 2 devices, one named controller and the other one named interface, and here the addresses that they have in the network. The addresses are important and useful to let the devices to talk each others. Selecting the first one of the 2 units, we can see here the physical device that is used for this unit. Here the name, the others, and the device ID to distinguish the unit from the others. And here the options that we decided to enable or disable, to include or exclude from the program. For example, here I've enabled the PWM, and here we have the list of the public events. So for example, here we have the start process, that is an public event that can be called with an RPC and receive 2 arguments, value and operation. And here other 3 more events, start process, abort process and resume process, that do not receive any argument. The byte caller is an system argument that is provided by the system and is to know who called the public event and have a chance to reply back to the caller. And here we have the list of the events we want to implement. For example, here we have the input selected, the out change, and the 3 timers. And changing to the other device, the other unit in the project, the one named interface, and the name and the others. Note the others is 3 now. The device ID is another one, and this one is an LCDG, which is a device that have a display. And again, here the options that I've selected. For example, here I've selected the RTC, and here again the defined public events. In this case, we have show status. That is a public event that receive an argument to display the status, so that the unit controller can call into the interface device this show status function and to display the status that the controller have. And here once more again the events here are selected: the click, the long click, and one timer, and the temperature change. And here we have another more thing. We have the list of the strings that are stored for this device, since this device is a unit that have a display and can display strings. So here, opening the display maker, here we can see the list of the strings stored for this device, and you can note that some of them are wrapped within brackets, and this tells the program that these variables have to be collected into the global array, while the other variables are independent variables and can be used, for example, to show a page, such as in this case we can see how the page will appear on the screen, and the pages and the strings can contain several information for formatting information, such as moving the strings on moving character on the screen, or displaying numbers, such as in the printf function in C, or to display or even to display strings, indexed strings from the global array. In fact, here we can see, we point to the ready variable that belong to the global array, and you can see the ready is the first one, then we have busy, heating, etc. And for example, we can change here the name alarm to see how would appear another string in the array. We need to put the first string, the first member of the array from which we want to index, so that providing any index from 0, 1, 2, etc. In this case we will display ready, busy, heating, cooling, mixing, and alarm. Now let's see how to make a simple Hello World program using this AppWizard. The first thing to do is to name the device and choose the model of the device that fit our purposes, and for this example I used one LCDG that have a display. Now I'm ready to add this device to the project, and here about options and public event, I don't change anything because I don't need them, and I click I selected the click and long click events that I want to implement to grab, because I want to grab which button the user presses. Now our device is almost ready, but we need to enter something to be displayed, so we click here to open the display maker, and here I enter the text hello world, and I give the name of the variable page 1, and I move the hello world to the third, say, and third row and third column, but I can change this because it's not centered, so I try fourth and maybe sixth, that's fine, and then I carriage return to feed, a line feed to go to the next line, maybe again the same thing, and I put this command to print in negative, and this other command here, this other command to print the date, the current date in negative, and again this command to format normal again. And this string for this page is ready, so I add this to the declare strings that are listed into this text box. And now I want to show another page that will show the status of our output. We want to change the output on or off, so we want to display the status of the output that will be changed. So first I add two more variables that are wrapped within brackets to direct the program to collect them into the global array of indexed variables. So here A will be named will be on, and B will be off, and finally the page 2 that will display the status of the output, and I use this command to enter the reference to the first string of the array, so that when we pass the first argument that will be the status of the output, we will display on or off. And now I'll add a couple of carriage return. I add an information for the user to remember him to long click to commit the action. And here it is. We have the strings ready to be included into our device, and finally we add the logo, our personal logo. You can design your own with a simple bitmap, and we are ready to generate the project. So I click here, so I selected the path where we want to save our project, and we can change here the name helloworld project, and we are ready to save and generate the project. And here the files that have been generated. This is the mine program code, the entry code program, and this is the header, and this is the actual implementation code where we will put the implementation code of our program. So let's see these files, and this is the mine entry program where we have the serial number and the other settings, but we have really nothing to change into this file. Here we have the header file, and we have the strings that have been generated with the display maker, and the main global collection of indexed strings, as you can see here, on and off, has been put into this global array. And here I've already put the code of our project. So here we have a global variable output status that will keep the information about how we want to change the output status, and the two prototypes of two functions, that one display the page 1 and the other one that display the page 2. And here in the helloworld.usr.c.h, this is the actual implementation code. Here we have the implementation, the initialization code that must be put here. So the first thing to do we do is to display the page 1, and here the code, implementation code for the events click. So we check if the key enter has been pressed by matching with the variable click that is passed by the event click, and in this case we will display the page 1. And here we test with if either the key up or key down button has been clicked, and in this case, in the case of key up, and if the output status is 0, we increase it to 1, or otherwise if the button is key down and the output status is non-zero, we decrease it to 0, back to 0. And here then is displayed the page 2, and the page 2 will display what the actual value is, the output status. And here the event long click, where if the key enter is pressed, we will set the output with the output status, and further we print this information as a debug. We put the number of the actual number of the output status onto the display. And finally, at the bottom here we have the two functions, display page 1 and page 2. First we clear the screen, and then with the function text out, that is pretty similar to the printf, we here print the page 1, here the page 2, and passing the value of the output status to indexing the on or off values, on or off strings from the indexed string to display the status of the output. So to test this Hello World example, I've prepared this setup. Here we have this, that is the display and controller, the LCDG Display and Controller, which is powered with this power supply, which carries 24 volts. It can work from 7 to about 30 volts of power supply. And here we have the ISP programmer, and here a 3 relay unit inside this that are controlled, connected through these wires to the output 0 of the controller, display and controller. And the relay control this socket that in turn is connected to this lamp. The program has been compiled and now it's ready to be uploaded. Accept this program confessor. And here we go. The program is ready, and you can see we have the logo. We charged our own personal logo, and the Hello World is appearing on the screen. We can see the watch is the date is not set, is not yet set. So to set the date and time through the network, I've connected this adapter that is RS485 to 232 adapter that converts the network of multiple devices into messages that can be read from the computer. So this is a little program that can be used for this scope. We open the port, we are online, we make a map of the devices in the network, and select the device we need, with this the only one device we have in this network, and click here to set date time, and that's it. And here we go. We have the date, the updated date, and let's see how the our program works. Pressing the enter button show the hello world screen. Pressing the up button change the output, prepare to change the output to off. Pressing down changes the output to on. Remember we purposely swapped the on and off to use the opposite sign to show the difference, to enhance the difference between how we can set the internal variable and how we can set the outputs. And now we can keep pressing the and now we can keep pressing the enter command to turn on the light and to activate, to commit the output. And here we can see the actual variable that we used for changing the output, that we printed as a debug information, and it is appended here. So let's try to change it to off, commit again, and we have the variable now is 1, and the light is turned off because we opened the relay. And that's it. It's pretty simple, straightforward to realize, to make applications with this framework. There's a lot of things about networking, what can be seen and set through a computer or any other device, for instance an ESP8266 that sends standard messages, private messages and more. It's a topic that would require a whole new series. Let me know in the comments if you are interested to see more. I've not made the code available on GitHub yet. And at the moment the code is of the whole framework is made for the ImageCraft ICC AVR compiler and for the AVR microcontrollers family such as 80MegaThirty-two, and with little changes in settings for 80Mega328 and other microcontrollers of the same AVR family. But it is relatively easy to port to GCC, which by the way is the underlying compiler used in Arduino IDE, and for other microcontrollers too. Also, the AppWizard and other utilities are legacy products for Windows XP, even though they seem to work fine in Windows 10. Even though I've made cool things with this system, I'm not sure whether this project would be of general interest. So I'd really appreciate any feedback, so if you have one, please leave your comment. And if you liked this video, also consider to like, share and subscribe. Thanks for watching, see you next time. Accept this programma confessore. And that I've revamped